I'd like to talk to you about something called a static local variable. Let's take a look, if we could, at the program on the screen. It has a procedure called show static that accepts no parameters. And we say, in main, we say for int count as 0, 0 less than 5, show static. So this is a call. We come down to the procedure show static, where we actually create a static local variable. We say static int statnum. Statnum is, and by default, it's set to 0. And then we make it 1, and the procedure ends. Now normally at this point in time, this variable would cease to exist. It would die. But in this case, statnum is still 1. We go back to main, where count is now 1, 1 is less than 5, and we call show static again. Now when we come back to the procedure, this line here is ignored, and the last value statnum had was 1, so we say statnum is 1, and now we make it 2. We go back to main, and we call show static again, statnum is 2, and then we make it 3. Now the bottom line is the statnum actually keeps its value. It keeps its value even after the function ends, and that's called a static local variable. The interesting thing about statnum is that it's only accessible inside this procedure. It's not accessible outside of the procedure. Now, up until this time, let's take a look at this program. Here's what would have happened. We have a procedure called show local, and in main we call show local, and we come down and we create a local variable. This is just a local variable called local num. It's 5. Local num is 5. Then it's assigned 99, and then it evaporates. We go back to main and we call show local again. Another local variable called local num, created someplace else in RAM, is created and initialized to 5. We display it on the screen, we make it 99, and then it evaporates. So up until this point in time, any variable that we created inside a function or procedure basically died when we got to the closing brace of that procedure. And up until this time, if we wanted a variable to keep its value even after the variable or the function ended, we would have to use a global variable. The problem with a global variable is that it's accessible by all the other functions, and that's not good. So what we now have seen in this section is the creation of a static local variable, and basically it's only accessible inside the function it was created within, and it does keep its value. It does keep its value when the function comes to the closing brace here. It keeps its value, so when it's called again, we can access the previous value that it had last time the function ended. So this is a static local variable. Maybe a simple example of using a static local variable would be, let's suppose that every time we came to a particular function, we were creating a new employee, and we'd like to keep track of how many employees we've created. We could have a counter variable inside that function that would actually be keeping track of how many times we got there. In order to do that, we would have to have a static local variable that would do the job for us.